So this one is creating factor pairs of expressions in the form a squared minus b squared, where a squared and b squared are perfect squares. Okay, there's a lot going on here, right? But I would say this. I want to remind you what perfect squares are. So I think I'm still in yellow. Yeah. Perfect squares, for example, are like 4 because 2 times 2 is 4, 9 because 3 times 3 is 9, 25 because 5 times 5 is 25, and it keeps going, right? An example of not a perfect square would be like 10. So not example. Not examples. Or like 10 because like 1 and 10, 2 and 5, like that's it. Like 7. 13. These are not perfect squares because you could find like a decimal that would do this, decimal value that would do this, but you can't like it's not gonna be like clean like this one. The square root of this is 2, square root of this is 3, square root of this is 5. You know. So let's go ahead. I want you to look at this. So I want you to take this 4 and put this over here. And take this 9. Ignore the negative. Ignore the negative. Ignore the negative, and just put that right here. And I want you to square root both of these. And really, you get 2. I mean, really, you get positive 2 and negative 2, but let's not worry about negative 2 right now, okay? And this is positive 3. Like I just told you, you can have the negative version of this because negative 3 times negative 3 is always positive 9, but we're ignoring this right now. So we have, let's do this. Or you know what? I'm going to write this in a different color because this is the process, just like the other one. Square root of 4, square root of 9 is 3, square root of 4 is 2. So I'm going to write 2x. I'll write it in yellow. 2x. So 2x. I'll put an x. I'm hesitant to. No, I'm going to leave that out. So 2x plus 3. We got the 3 from over here. And then just write it as the subtractive version of it. So 2x minus 3. So together, and it'll be easier once we go, like, we'll do more examples. So together, 2x plus 3 and 2x minus 3 form a factor pair of 4x squared minus 9. And this is because 2x plus 3 times 2x minus 9 equals 4x squared minus 9. And you could prove that like in the other one, but I think it's easy. It's better if I just show you more examples. So let's take the square root of 16 and the square root of 49. Oops. Oh, there we go. Oh, I didn't even leave any room for the answers. The square root of 16 is 4. Square root of 49. Remember, we don't care about this minus right here. Is 7. So we can write this as 4x. Remember, we get that 4 from right here. And then we'll put plus 7. And we get that 7 from right here. Times, 4x minus 7. Something about that looks a little weird, so I'm going to write this a little differently. I think it's just because it's not straight, maybe. And then this 7 came from over here. And then you do that subtractive version of this. Okay, maybe it's the 7s, you know? So together, 4x, I'm going to put this one first. It doesn't matter to me. 4x minus 7 and 4x plus 7 form a factor pair. Factor pair of 16x squared minus 49. because 4x minus 7 times 4x plus 7 equals 16x squared minus 49. Okay, we have some more examples apparently and some proof. So let's do this one fairly quickly. So let's do square root. Oh, this is more complicated. That's why I gave it to you. Okay, so square root of 100. So, okay, I'm going to do this. Technically, we're supposed to be doing this, right? I like to do it like that. So we get 10. But what times what is x squared? X. Oh, that's why I did it. Okay. I won't get into that, though. And then square root of 25 is 5. Square root of y to the 6 is actually y to the 3rd. This is like a bonus feature just in case you see a hard one that you want to do in the practice. So you would write this one as 10x plus 5y to the 3rd times 10x minus 5y to the 3rd. Those of you that are wondering about y to the 3rd, this is y times y times y. And if we multiply it again by y times y times y, you're really doing it 6 times, y to the 6th. Okay, let's move on from that slight craziness. I'm going to write it like this. And what times what is 25x to the 2nd power? Well, that's really 5x. And what times what is, oh, I can't do this one. You see this plus sign? That means cannot do. Watch out for these. Has to be subtraction. Okay, cool. And so let's do this one. Let's square root that one. Square root that one. Square root of 144w to the 2nd power is 12w, because 12w times 12w is 144w to the 2nd power. What times what is 81? Well, actually, let me write that w a little better. Okay. What times what is 81? Well, that's 9. Square root of 81 is 9. So you get 12w, plus 9 times 12w minus 9. And let's go ahead and prove that, okay? So 12w plus 9 times 12w minus 9. 12 times 12, 12w times 12w is 144w squared, because w times w is w to the 2nd power. I keep writing that w all weird. That's as good as it's going to get, I think. And then 12w times negative 9. Oh, I need to calculate this one. Using my calculator. Oh, no, I know this one. 12 times 9 is... 10 times 9 is 90. So then we have 18, 108. So, hold on. Positive times a negative is minus 108. W. And then positive times a positive is a plus. Same numbers, 108. W. And a positive times a negative is a negative. Now, if you notice, the reason why we need a positive version of this expression, well, 12w plus 9 and sort of like this, well, the reason why we need to say plus 9 and we needed to say minus 9 is so that when we put these together, they just go away. They're just gone. Like, they're gone. I'll do that. I'll put it in green. When I attempt to put these together, negative and positive version of themselves, they're gone. So then I get 144 w squared and minus 81, which is what I was originally trying to represent, or what I've been trying to represent. Okay, and we have this last one. But look at this last one. This is a perfect square. Like, I can do 4x times 4x. This is a perfect square. I can do 6 times 6. But this is addition. Cannot do. Exclamation mark. And that is it. Thank you.